In this video, I'll talk about two examples of analysis that used multiple people and multiple measurements that used methods that are discussed in the book. So the first one is this study that I did together with Eiko Fried in 2020, which is published in the Clinical Psychological Science Journal. And the nice thing about this study is that all the data and code are available online on the Open Science Framework. So you can play around with it yourself, do your own analysis. In this study, we analyzed 80 undergraduate students at the University of Leiden in the Netherlands over a period of 2 weeks, measured 4 times a day. And the interesting about the study is that it was set up, everything was set ready to collect data in March 2020. And then the Dutch government announced the lockdown a few days before that, which of course we didn't know when we were setting up the study. But Eiko managed to get ethics clearing for a few more variables in the study to also include relationships between on COVID-19 and worrying about that, for example. So it was really in the first 2 weeks of the lockdown in the Netherlands that we gathered this data, which makes it quite interesting data in an interesting time of these people's lives. These are the variables that we measured. A subset of them that we included in the networks. Mainly stress-related variables and things about COVID-19. And also some social variables. Then we estimated these networks. So we get the contemporaneous and the temporal network. I didn't include the between person network here. It wasn't that interesting, so I only include these two here. And these networks were quite interesting. I thought they showed some interesting relationships. For example, we see a strong contemporaneous effect between being occupied about COVID-19 and being worried about COVID-19. That makes sense, right? We see a negative effect between being social offline and being social online. That makes sense. We see a very strong negative effect between being home and being outdoors. Well, that also makes sense. Right? But it's nice to see that the model picks up these relationships that make sense, that we know that makes sense, because that gives us some confidence that it's doing what it's supposed to be doing. The one thing I found interesting here is this pathway here, the temporal effect, where we see some interesting pathways between feeling alone, having a temporal effect on worrying about COVID-19, having a temporal effect on being occupied by COVID-19, and that had a lot of these outgoing temporal effects to a lot of the stress-related variables. So for stress-related variables, there were temporal outgoing effects to 4 of these stress-related variables, which I thought was interesting. Of course, in this time, people were very worried about COVID-19, very occupied about it. It was basically all you were talking about, of course. And this also showed that there was quite some temporal effects from that variable. And of course, all these temporal effects have these blue autoregressions, which means that they were also stable over time. So, if you want to know more about this, then feel free to read the paper. There are more conclusions that we draw from this network. So this used time series data. So we had 2 weeks of measurements, 4 measures per day, so quite a lot of observations per person. The second example I want to show is a dataset that is not time series data. So this is a panel data set where we only have 4 waves of data, but a much larger sample size. Now the sample size here is over 1,000 people, but we only measured people 4 times. Well, I didn't. I wasn't involved in data collection here, but in Norway, the data here is also in period of COVID-19. The gap between waves is much larger than days. I think it's a month or 2 months or so. Lots of variables were included in here. These were the ones that we analyzed in this study, which was about PTSD and coping strategies. And one thing that I found really interesting here, so I only included temporal effects here, but if you want to see the contemporaneous effects and the between subject effects, you can read the paper. One thing I found interesting here is that this node here had a lot of outgoing temporal effects, which is not something I usually see in these types of temporal networks. So I found that interesting. This is using substances to cope. That means that people would drink alcohol, for example, to cope with their PTSD symptoms, which had quite a lot of outgoing positive temporal effects to these PTSD symptoms. Positive, of course, meaning not good, right? Increasing symptoms. So that means that using the substance to cope wasn't particularly helpful in this setting. And that's a nice, interesting conclusion. Again, if you want to see more, you can read the preprint. The study has been accepted for publication now, which is nice, but it hasn't been published yet. This method, this final one, has been implemented in the R package that I'm working on now called Psychometrics. And this is actually the main part of my work on network modeling, where I made a very large R package for maximum likelihood estimation. So it doesn't use Lazoo regularization or anything. You do thresholding and model selection in it. And mainly what it does, it allows you to do things that we can do in structural equation modeling with network modeling. So if you know structural equation modeling or confirmatory effect analysis, you know there's quite a lot of things we can do in SEM, like model search, model selection, modification indices, handling missing data, measurement variance testing, latent variable modeling, measurement error, things like that. That because of this package, we can now also do for network modeling. And this model is actually a variant of what we call the random insight cross-select panel model for that we use structural equation modeling, but then with more networks in there. So this package has a lot of models for cross-sectional data, for time series data, and for panel data. You can do Ising modeling there, Gaussian graphical modeling, vector autoregression, these random insight cross-select panel models, or these panel versions of the vector autoregressive models, things like that. Allows for multi-group estimation, missing data handling, all kinds of nice things like that. So if that's something that you're interested in, then feel free to send me an email. I can send you some more information or some papers. The development of this package is one of the main things that I'm working on now. And also mainly this type of analysis where we do estimate these type of networks from panel data sets with only a few waves of data but large sample sizes is a main topic of my research now. So something that I'm very interested in working on. Okay. That's it for all the videos. So thank you for your attention and good luck with the remainder of the course.